First, let me try to explain what's happening here. This is material that never seems to quite get in the textbooks. And yet, I think it's incredibly important for statistics students. And it's mostly centered around the fact that people misuse statistics so frequently that that's why it's titled, you know, How Not to Be Lied To. Notice my two main sources on here. I'm pretty sure we have both books in the library, but especially the one on the bottom, Darrell Huff. His book was How to Lie with Statistics, and that used to be the title of my presentation, but I didn't want to mislead people. Honestly, I'm not trying to show you how to lie. Actually, just the opposite. I want to show you what a lot of people will do either knowingly or unknowingly, and of course, you don't want to be fooled. So that's the idea. I just thought this was interesting. George Gallup is a Christian. You've all heard of the Gallup poll. He, I say, is a Christian, was. He died in 1984. But I thought this was an interesting quote from him. I could prove God statistically. Take a human body alone. The chances that all the functions of an individual would just happen is a statistical monstrosity. Yeah. So anyway, that's not my main purpose, and this is the cover from Darrell Huff's book, and I really like it. It fits the topic so well. You notice the guy is kind of sweeping the numerical facts under the rug, so to speak. Yeah, that's a good picture of the type of thing we're talking about today. Okay, so on we go. This is the list of separate things that I'm going to be showing you today. Maybe some of them are going to be quite short, but these are all what? Bad uses of statistics, each one of them. One at a time, we're going to just go through those, and I want to show you some examples. So the first of that list is making assumptions. And I have some examples for you here. Here's the first. In 1999, former VP Al Gore told school children that the summer heat wave on the East Coast was evidence for global warming. And then you're going to see basically scientists' rebuttals coming up from the bottom. Here's the first one. Much of the debate over global warming is really beside the point because the key assumption that there is a scientific consensus on climate change is false. Everybody, all the media want to tell you, oh yeah, it's a fact. Scientifically, everybody agrees. As you notice, this is George H. Taylor, state climatologist for Oregon and president of the American Association of State Climatologists. Obviously does not agree. And it really ticks me off that the media gives the impression that a lot of this stuff is all, you know, it's like a fact. Another one, promoters of global warming fears have been busy blaming storms, floods, droughts, disease, and all kinds of misfortunes on the atmospheric increase of greenhouse gases. Now, by the way, just so you know, I do recognize that there has been an increase in these greenhouse gases, and yes, we do need to do something about it. I just don't believe there's this huge panic like a certain former vice president has tried to make us all believe. And you're going to see I have some pretty big guys on my side. In this case, it wasn't the VP, it was the former president. Former President Bill Clinton in New Zealand, again, talking there, blamed it all on the use of energy, that was the problem. And there's a lot of people that disagree with that. This thing on the bottom basically just says, hey, drought occurs in almost every region on Earth on a somewhat regular basis. You can't say drought is because of something called global warming, especially since we haven't agreed there is global warming. And again, this is no floozy from a back alley who's been drinking bad wine. This is State University of New York distinguished professor in the Department of Geography. Patterns of relatively wet, dry, hot, cold weather usually run in 6 to 8 year cycles. But media attention combined with our poor memories of the past weather tend to generate unjustified alarm for our climactic future. Here's another one. I'm sorry, but Al Gore is such a good example because he has done such incredibly bad things. By the way, I don't know if you're aware of this, but Al's presentation on global warming has gotten a lot of attention. I don't know if you're aware of this, but he got C's and D's in science in college. So, and the reason I'm pointing that out is his, I hate to say it, but his big presentation with all his impressive graphs are based on some pretty crummy statistics. And you should be aware of that because I don't want you to be lied to. Or, I'm not sure he's lying. I'm not sure he knows better. But it's not true. Let's put it that way. Anyway, you see here in 1997 there was a terrible flood on the Red River right between North Dakota and Minnesota, and he was talking about that, and he attributed it to El Nino and climate change. As you can see at the bottom here, an article in USA Weekend by two Weather Channel meteorologists, Colin Marquis and Stu Ostro, argues that the weather is pretty much the same as it always has been, and that only our perceptions have changed. One of the reasons why we may think the weather is wilder is the massive growth in media coverage. And one more, flood damages. Oh yes, this is maybe my favorite of the list of making assumptions. This, by the way, is a true fact. Flood damage and flood deaths have generally increased in the last 25 years. Right away you think, oh my gosh, yep, global warming. No, actually, you know what it is? More and more people are buying houses in floodplains. Especially the rich people. Well, I shouldn't say the floodplains, but where do rich people often build homes? They build them on coastlines where you have these incredible views. Right on, especially on the East Coast. What's the problem with the East Coast? When a hurricane hits, that's the first thing they hit. And they're just set up for problems, okay? I mean, hurricanes are pretty nasty things with over 100-mile-per-hour winds. Anyway, more and more people are buying properties like that, building expensive homes, and having damage. And the one that really gets me is people who buy houses that are below sea level. Please, when you buy a house someday, don't buy a house that's below sea level, because you're just asking for flood damage problems, okay? So one of the first things you check when you're buying a new house is the area will have done a research report on whether your house is what they call in a floodplain. And if you find that it is, boy, I'd really be skeptical about buying it, okay? Because then if there's any kind of heavy spring rains or the river or lakes that are nearby often will just come into that area and cause big problems. So anyway, what this says is there's been a huge growth in people buying. A good example of houses below sea level, and I'm not saying all these people have a choice, is in the New Orleans area. I don't know if you're aware of this, but most of the city of New Orleans is below sea level. And it's only protected by these dikes that they have built. And when those dikes failed, we saw the tragedy that occurred. So, I mean, some of those people I'm sure don't have a choice, but just for your purposes, if you ever have a choice, don't buy in a place like that. Buy on higher ground. I'm not saying nothing wrong with Louisiana. Just get above sea level. You'll be happier. Your house will last. Okay, we're on to topic number 2 now, which I call overwhelm your audience. It's pretty easy to do with statistics. And I don't have some huge examples here, but I have just a couple to get you thinking about it. You know, these are kind of humorous slides to get you thinking. You know, chances are, and you just throw a whole pile of numbers at people, and then kind of joke. Chances are 92% that I can make sense of this. You know, actually what happens is when people throw up a lot of impressive bar graphs and statistical words and things like that, most of the, 99% of the people in the crowd are like, this guy must really know his stuff. But they really don't get what he's talking about. And so it's pretty easy to do. What I call the percent lie. Now, let me explain. You know, here's just a simple claim 3 out of 4 doctors recommend. Okay? You've all heard the commercials. Usually they're 9 out of 10 doctors recommend, right? They are 9 out of 10 doctors recommend, and you can fill in the blank. There's certain kind of cough syrup. Okay, what do they seem to be telling you when they say that 9 out of 10 doctors recommend? Aren't they implying that 9 out of every 10 doctors recommend it? But, I mean, think about it. What do you think? Did they really ask every doctor? No, that's impossible. You know, it's possible they may have only asked 10. And maybe 9 of them said yes. And the 9 that said yes may have been given, you know, free cough syrup for life. I don't know. They do that. Manufacturers will do that. They say, if you endorse our product, we'll do this for you. And they'll pay them to do the commercial. Okay? I mean, you just don't know. And what I'd love to ask the commercial people is, oh yeah, can you tell me about your sample? Of course, you can't talk back to a commercial. So you got to be careful. Here's another one. See what you think of this. So this is a little humorous thing that teaches a pretty good lesson, I think. You see this boy, he's doing some campaigning for a school election, and he's pointing to this graph, and he says, 21% of the boys and 30% of the girls support me. Therefore, I'm going to get 51% of the vote. What do you think of his campaign, his concept there? Is that how percents work? No. You can't add percents. In fact, he's in deep trouble. He's got, what, a really lousy percentage of the boys and a not so hot percentage of the girls. He's probably got overall, my guess is, maybe about 23%, somewhere in between is going to be where he is. But we can't tell because we don't know what the numbers are. But this guy is in deep trouble in the election, and this is false, completely false thinking. So I'm glad for him. I hope he feels good about himself, but he's going to have kind of a rude awakening on election day. And then you can easily overwhelm people with terminology. Now, some of these terms you've seen in our class. But some of these we haven't had an advanced enough statistics class to talk about. I mean, I'm sure all of you have seen percent level, percentile. We talked a little bit about confidence level, standard deviation. You've heard regression. This we have not had in this class. Actually, this is just another name for the normal distribution, so you've heard of it, but I didn't use the word. We talked very briefly about degrees of freedom. My point is, I could pull out a lot more. It's pretty easy to bowl people over because most people don't have a lot of stats background. And I hate to say it, but this is what a lot of people will do. Okay, topic number 3, I call graph-related lies. This one really bothers me, and people misuse this all the time. The first one, you're going to think I made this up. Change the scale on the y-axis to your liking. Can I be serious about that? Actually, I can. People actually do it. All right, let me give you an example here. Now, by the way, don't get upset if I start acting weird here. I'm actually going to do a little bit of acting here, okay? Make believe we're in a town meeting. I don't know, some little town, we'll call it Podunk, okay? And you guys have come to the town meeting, and I'm a citizen that's got up and asked for the floor. Citizens of Podunk, do you believe what the government has been doing lately? Look at the spending graph. I am so ticked off at this government. You should impeach every single one of these guys. All right, Mr. Jones, your time is up. Okay, now on comes guy two. This is Mr. Smith. I don't know what the problem is with Jones. This is a more accurate graph of what's happened to the government spending. And yes, it's gone up a little bit, but really just because of inflation. So I don't know where he's coming from. That guy's got a problem. Okay, now my time is up. Okay, now who told the truth? Well, I'm going to put the two graphs up together. These actually are both graphs of the same data. Now, let's analyze them a little bit. What's the big difference between these two graphs? Look carefully at the two graphs. It's subtle. Look at the units. Okay, notice on this one, you can't really see any marks for units on the side, but you can see that this is what, 20 million, and this is 19.5 million. So this is obviously not zero, right? Now over here, we've got it marked 20 million, 10 million, 0 million. Here, we've got a 0 on the graph, even though it's not marked, it's in scale, 10, 10. Honestly, I mean, I was not making any comments in reality about Podunk. This is actually a more honest approach. Graphs without 0 are highly questionable because if you take 0 off, you can make any graph look really exaggerated, okay? Yes, I'm a little concerned about the increase here, but it's not like, oh my gosh, look at it. They spend all, it's not dramatic like it is here. And this is really a more accurate view. So here's a little advice for you. If you are viewing a graph and it has no 0 on it, be really careful about getting a lot of information from it because, it's just not good. You should have a perspective on 0. Okay, now here's another favorite thing that people will do. Don't show the whole graph. You got to be kidding me. They hide part of it? Yep. And here's how they do it. I don't know if you've ever seen a graph like this, but we have a bar graph or a histogram here. Now here we have a 0, so I can't accuse these people of not putting a 0 on here. But there's still a problem. Look at these units. From here to here is 50,000. From here to here is 3,100,000. No. Here, 50,000, 50,000, over 3 million? No. And you know what the key is? This tear. They actually put like a tear mark in a graph, which means, I'm telling you the truth here, part of this graph is missing. That's what that tear means. Duh, it's like, I'm telling you the truth, but I'm hiding something from you. Okay, if these graphs were accurate, they would go down about 2 stories more. And then you would see the full bars, and then you would go, oh, those bars aren't really much different in height. Right now, they look kind of dramatically different in height. So it's the same old deal. If I wanted to get you upset, I might want to show you this graph and say, look at how this has gone up. And if you saw the full bars going down 2 stories, you'd go, yeah, they're a little higher. And you'd see a whole different approach. So once again, so this is like, all right, we'll show you the 0. We'll make you happy. But we're going to take out a good share of the graph. Yeah, that's baloney. And I know why they do it. They do it because maybe they don't have room, but it's not so hot. Now, here's one that's really subtle. A 3D, you probably haven't heard of this, but have you ever, yeah, well, let's talk about it. Have you ever heard of a pictograph? Yeah, what is a pictograph? It's literally a graph made with pictures. USA Today likes to do this a lot on their graph on the front page. They call it USA Snapshot. Anyway, what it is instead of just putting bars, and if we're talking about people, they might have people of different heights. Kind of a clever way to show you a bar graph, and yet, make it a little more attractive. But anyway, watch this one. Check this out. Okay, here we have a picture of kind of a line drawing of a guy with a bag of money. And you notice by the shading, aren't they trying to give you the impression of three dimensions here? Yes? I mean, isn't that what the shading does? Makes it look more three-dimensional. Okay. Now, let's say I'm talking to you and I say, guys, do I have good news for you? Guess what? We have had such a good quarter, I am going to double your pay starting today. Woohoo! And as I say that, I display this graphic. I just lied to you. But you probably don't know what my lie is. And again, you see the three-dimensional image. Now let me tell you, that bag is twice as tall as this bag. So it seems like my graphic is correct. But now, a little principle for mathematics. Not only is that bag twice as tall, isn't it also twice as wide and twice as deep? You know what happens to the volume of an object when you double the length, the width, and the height? It gets multiplied by 8. So as I was telling you I was going to double your salary, I put up a bag that's holds 8 times the money. So if I really wanted you to feel, wow, is this boss fantastic, I might throw that up there. That was not a good choice. Now, had I made that, that's the trouble with pictographs. If I really was going to do it right, I could have done it. I could have used this height to this height being a ratio of 1 to the cube root of 2. Then it would have been accurate, but then it wouldn't have been so impressive. It also would have been the truth. So that is a subtle one. So I guarantee you you can hold 8 times the money in that bag on the right, okay, not double. And I can just hear a politician going, oh, no, I told you the truth. Honestly, that bag is twice as tall as that one. Yeah, that's true, but you lied to me with your three-dimensional, and too bad you don't know any math. Are you sure you want to run for office? I want to vote for a guy who can add. Okay, on we go. Here's another clever one that's often used. This one called use perspective to stretch the truth. And again, this one's subtle. Okay, we have kind of a picture here. This, by the way, all these examples are real. I actually took these from real things that were put out. I didn't make any of these up. Here's one that they ran in a magazine about fuel economy, which has become a big issue again, but this is from years ago. And this is clever. They used a highway, which is a really cool idea for a graphic because we're talking about gas mileage. Okay, now, just take a look at the numbers here. What they're saying is, in 1978, the standard by Congress was 18 miles per gallon. In 1979, they pushed it up to 19 miles per gallon. In 1980, 20. Okay. In 1985, 27 and a half, et cetera, et cetera. Okay. Now, you probably don't spot any problems here. Well, I'll give you a clue. Let's just take the number 18. Okay. What's I'm trying to think of a good ratio here. Yeah, let's take what's 1.5? times 18. It would be 18 plus a half of 18, so 18 plus 9 would be 27. So when we go from this 18 line to this 27 line, this line should be about 1.5 times as long as the 18 line. Let's see. 1, 2, 3, 4. It's about 6 times as long. Boy, have they blown that up. Now, what's clever about it is it's perspective, and when you do perspective, this is the way things appear. They do appear much bigger as they come closer to you. But it's just, it looks like, man, has Congress come a long way to get to here, and it looks like it's impressive. Whereas, I mean, this is exaggerated. It's not the best. They could have done it so it really was in the right proportion, and that would have been total honesty. So, if I really want to build up Congress and say, look how great your Congress has been working for you, look at what they've done. That's exaggerated, and it's not totally true. Another one is, how about using a larger scale for scatter plots? Okay, you're going to see 2 scatter plots come up on the screen here. Okay. Now, the question is, on which one of these scatter plots do the points look more gathered together, more bunched? And the answer is neither one. But don't they look more bunched here? All I did was change the scale on the graph. Here, you notice it goes from 0 to 180. Here it goes from 0 to 310. Because there's more space around it, they look more lonely, and they look more gathered together. Common trick that's used. So if I wanted to say, oh, I don't know, these points really came out to be quite orderly, I could make sure I change the spread on. And by the way, you got to go through a lot of shenanigans to change the graph. You know how the automatic ones come up more like this. You can do it. And then you can say, oh yeah, look, we did a pretty good job. Yeah, it's not totally honest again. And all these shady ways to present statistics. And then, this is the topper of all. And I'll just try to point out a few things on here. This is, like the article says there, this could be the most leading graphic ever published. Period. It came out, as you can see, in something called the Ithaca Times, or Ithaca, New York. And it's talking about, as you can see, why does college have to cost so much, which of course is a worry. But the statistics on this cover are unbelievable. They have committed so many statistical sins on here that I can't believe they printed it. We're going to just show you a couple of them. Okay, the first one, the ranking. By the way, the 2 graphs are, this one is the cost, and this one is the ranking. Okay, so what it's supposed to do is whack you right in the face and say, holy cow, the costs keep going up and the quality is heading down the tubes. We're paying more and more for bloody education. Okay, that's what it's supposed to scream out to you. Oh my, is that misleading? Because, by the way, this is rank, and when the rank goes down, that's good. When the number of a rank goes down, that means you're closer to the top. Like if you were 15, then you went down to 2, your college is doing better. But the way this is presented is like, oh, well, stupid college is doing worse. So that's just totally wacko that they would present that. That's one. Then the other one is the ranking. This one only covers an 11-year period. This one covers a 35-year period, but they slap them together. You can't take 2 graphs and just glue them together with different scales. Anyway, here's another one. They took this graph and they rotated it 90 degrees. Oh yeah, there's much more. I'm not going to spend any more time on it. But point is, when the average guy on the street picks this up, he goes, yeah, look, yeah, college education in Ithaca, New York, he's going down the tubes and doesn't check the facts, and he's totally misled. Okay, that's it for graph-wise. Then we're just going to talk a little bit about the term average, which all of you, of course, are fully aware of. The first one is that it's used loosely. And I've already shown you this example. The one about Ralph Sampson, do you remember him being a University of Virginia communications grad? And in the brochure for the department, they wrote that the mean average starting salary was $55,000, which is actually true. But the problem is they had Ralph Sampson's salary in there, which is a unbelievably atrocious outlier. And it's completely, and you know that the mean is really susceptible to that. So they should have used the mean. So here's a case where they shouldn't have used the average, and they did. And I don't really believe they were being malicious here, but it's misleading. Okay, doesn't mean very much. Now this is kind of a humorous example, and yet it's accurate. So I thought it would be a good one. Often an average, well, no, this one's not humorous. I got the wrong one. Sorry. Often an average, whether mean or median, specified or unspecified, is such an oversimplification that it's worse than useless. Knowing nothing about a subject is frequently healthier than knowing what is not so. And a little learning may be a dangerous thing. I don't know, you may have given that speech to your parents. A little learning is a dangerous thing? Maybe not. But anyway, watch what happens as we go on. Altogether, too much of recent American housing has been planned to fit the statistically average family of 3.6 people. So what they did is they just went to the census and said, what's the average family size? And it happened to be at that time 3.6. And they said, well, we got to build a lot of housing for families that are of the size 3.6. Okay, they already made a big statistical error. Think about this for a minute. If 3.6 is the average, does that mean the majority of families are 3.6? You know, what is an average? Does the average tell you about the majority? No, it just tells you kind of when you put them all together where they wind up. Couldn't it be that there was a lot of dinky families and there's a fair number of small families and they average out somewhere in here? Yeah, and so you see the problem is right away they made an assumption. If that's the average, oh, that must be what most of the families are. And that's, of course, not true. By the way, the translation is, as you can see, 3 or 4 people in a family, which means probably 2 bedrooms. And so what the housing family did, the housing group, I'm not kidding you, they actually did this about 10 years ago. They went out and built a ton of 2-bedroom condos, houses, apartments. And guess what? They're sitting there empty because they didn't know their statistics. Turns out, even though the average was 3.6, that was not at all what the majority of families were like. And this but literally broke the bank. Many of these people went out of business. Just to finish the story up here, this is what they said. We build average houses for average families, say the builders, but they forgot about their statistics, and that doesn't tell them what the majority is. And you know, they looked at the census and they said, oh, the average is 3.6, almost like it was some divine statement, and so they built and they lost their shirts. Okay, so here's a case where not knowing statistics literally made some people go broke. Quite a few, by the way. Okay, and then misleading conclusions. In a similar vein, let me ask you, what about that question at the top first? Do half wage earners earn less than the average? Is that true? Do half the wage earners earn less than average? The problem is, again, does average have to be where the highest part of the pile is? No. And in fact, what did I tell you about income? Doesn't income go like this? Skewed to the right? You remember that? What does that mean? It means probably the biggest pile is on the lower end, and then it stretches way out to the right. There's always these people out here who do real well, but the majority of people are actually below average. Okay, so actually, this is not an accurate statement. Okay, look at it. Here's another humorous one about this. Bearing in mind the few Welshmen who, for one reason or another, have the misfortune to have only one leg. Okay, there's a couple people in Wales that have one leg. Okay, I know, where am I going with this? So if you took all the legs of all the people, all the men in Wales, and added them all up and divided by how many people there were in Wales, you would have the average number of legs, wouldn't you? And because there's a few people who don't have two, and by the way, there are none that have three, guess what the average comes out to? Something like this, 1.99995. And so, it can therefore be stated in all honesty that 99.95% of the Welshmen have more than the average number of legs. Because 99.95% of the Welshmen have two. So that percent of the population has above average number of legs. That's actually true. It's stupid, but it's true. So do you see why you got to be careful with the use of average? I mean, this is actually an accurate claim. I don't know why you can, obviously you're not going to make a claim about legs, number of legs of Welshmen, but you can see it's just like this one up here. Okay, so be careful with average. While average is a very valuable tool, it can really be misleading. Okay, now you guys know about this, so this is kind of a review. If you have a lousy sample, you're not going to get good statistics. And just a quick review, what happens if the sample is too small? Well, you know, and the reason I don't have a better picture is this. You know, they say 3 out of 4 doctors recommend. I mean, what if they only asked 4 doctors? It's possible, and they could claim they told the truth. I really did ask 4, and 3 of them said yes. But when they make the statement on the commercial, it sounds like 3 out of every 4 doctors. And so a lousy sample, you guys all know, is not going to give you good statistics. And of course, if the sample's not random, this is not good either. You know, if you look close at this slide, you can probably see he's peaking. And so, you know, if you don't really make random choices, then your sample is kind of meaningless, and you're not going to get good results. And then, of course, what about bias? This is one of my favorites. I don't know, do any of you have any of you ever driven on the freeway in Chicago or around the Chicago area? You know that they have toll roads everywhere. And now that they've automated them a little bit, you can buy these stickers. But still, if you're driving through the Chicago area, you have to stop and pay your toll. And there's traffic jam at every one of those things, well, just about. Anyway, here's a picture of these guys lined up. And the person in the toll booth says, "Excuse me, would you mind answering 50 or 60 questions?" And if you know anything about drivers in Illinois, the guy behind you is about to shoot your head off because you're going too slow. Okay? They're incredibly impatient. If you go 15 miles over the speed limit, your life is in danger because you're going too slow. Okay? I'm sorry, it's just the way it is in Illinois. They're like maniacs. Okay. And so, as they're waiting here, if I just hurt somebody, my apologies. But it's pretty wild. And of course, if you go to any other really big city like LA, it's even worse. Well, you probably know, they've had shootings on freeways because people are ticked off at other drivers. And I'll have to admit, I'm not the best on road rage either. But anyway, Check this second question out. Again, guy in the toll booth says, on a scale of 1 to 5, how do you feel about keeping people waiting? So the problem is, would this be a place to do a survey? Oh my goodness, no. Huge bias because people are in a hurry. Okay, the next topic I call withhold important facts. Two examples here. This actually happened in London. The Daily Telegraph is a big paper in London, England. Anyway, they made a lot of a decline in what they call football. What they call football is soccer. But anyway, they were a little bit upset that the football attendance had gone down. And they showed these statistics. Okay, here's, Division 1, here's the attendance, here's what it was last year. Division 2, it actually went up, and so forth. But you notice overall, it went down. And so they're like, well, what's the deal? Are people losing interest? Oh, did they leave out some important facts? It turns out that there were less matches. And actually, the attendance had gone up. Because in less matches, they hadn't gone down that much. Do you follow? So in other words, what they should have done is like an average attendance for each. Here's the case where an average would have helped, and they didn't provide it. So they didn't do it intentionally. But if they'd have given you all the facts, their article would have been completely reversed. The headline might have been, attendance goes up. And it was just the opposite. So it just turns everything upside down. Here's another one. Yeah. Okay. I don't know how many of you have seen An Inconvenient Truth, the documentary, the award-winning video that Al Gore hosted and talking about global warming. This is the big graph that everything was based on. It's gotten so famous that they by the way, they call this the hockey stick graph because it kind of looks like a hockey stick. Okay, that's why a lot of people are referring to it as. Okay, so here's what the whole thing is based on, and they're like, oh my gosh, look at the temperatures. Boom. Okay, global warming panic. All right, now if this graph was correct, it'd be something to worry about. The problem is, you see where this graph starts? This is the Middle Ages. This is the year 1200. This is the year 1000. Okay? There's not a lot of temperature records from the Middle Ages. I'm being sarcastic. There are none. Okay, nobody kept temperatures in the weather department in the Middle Ages. Well, what they were supposed to use here is tree ring data and things like that. Okay? But it's arguable how they interpret it. Watch, I'm going to show you another form of this graph that some other scientists put out, and you'll see a huge difference. But anyway, let's just go on. I want to tell you a little bit about this. First of all, there's been a lot of and this is, I got England, but all over the world. There's been a lot of rebuttals to what the Inconvenient Truth has come out with, as you can see from these headlines. Okay. A lot of scientists disagree. It really ticks me off that in that documentary, they give the impression that all scientists agree, and they don't. Here's just one that was on TV and saying, this is all a bunch of baloney. By the way, here's a graph from November 1996, National Geographic, and it was in an article called What's Going On with the Climate. You notice the problem? In the last 96 years, I hate to say it, but temperatures have been going down. And if you only go back 20 years ago, there was, by the way, a huge warning in the newspapers, magazines, and everything about global freezing. Just so you know, that was predicted. So, you know what the bottom line is? They don't know. Now, here's that graph I was showing you before. Here's the one the other scientists published. Okay, now, again, here's that dramatic increase that they talk about that we're in right now. But if you look at the other scientist data, look at where the temperature's been. This is natural alarming. We've been there before. Life has gone on. And so Gore, in his presentation, makes it look like it's such a slam dunk, and it's not a slam dunk at all. Next. I didn't make this up. Some people will actually do this. If they don't like the way a study came out, do it again. And keep doing it until it comes out the way we want it to. I kid you not. And that is totally unethical. But honest, it happens. Okay, I don't have any demo on that one. Definition of terms used. Sometimes you can just mess around with terminology. For example, look at this. A politician or somebody made this statistical claim. And this was quite a few years ago. Today, electric power is available to more than 3/4 of U.S. farms. Okay, now first you're appalled because today, of course, it would be terrible if any farm didn't have electric power. But if you can think back to like the Depression years, but the key is, what about these words right here? Is available too. That could be interpreted anyway. Like, well, yeah, if you just ran an extension cord 20 miles down the road, it's available to you, Joe. You know, I mean, this could be stretched to any definition. And so, I hate to say it, but politicians play with words all the time. Danger in prediction. Okay, now this is humorous, and please try to follow this. In the space of 176 years, the lower Mississippi has shortened itself 242 miles. By the way, that's actually true. Now, let me explain. Here's the deal. What happens is, over the years, the jags and the curves in the Mississippi River, or any river, what happens? As the water keeps flowing, some of the jags get knocked off, and the path gets straighter. And that's why it can actually get shorter. You follow? It doesn't mean the river actually went and shrunk. But you can actually make the trip now down the Mississippi and put on less miles than you could 176 years ago, simply because the river keeps changing in shape because of flow. Okay, so actually that's true. That's not made up. But now, somebody went on this and said, all right, let's make a projection. By the way, they averaged it out as about a mile and a third every year. Okay? Therefore, any calm person who is not blind or idiotic can see that 742 years from now, the lower Mississippi will be only a mile and 3/4 long, and Cairo and New Orleans will have joined their streets together and be plodding comfortably along under a single mayor and a mutual board of all. By the way, Cairo is southern Illinois. So you follow it saying, well, if the Mississippi keeps shortening itself by a mile and a third every year, then Cairo and New Orleans, hey, they're going to just join. They have one mayor. Okay, pretty funny by Mark Twain, but what is he saying? Can you take any pattern in the past and project it into the future? Oh, you want to be real careful about that. Okay, thanks. I got a couple more, but we hit the main ones.